Hello everyone. Human history, if compared to an endless night sky, would be filled with countless stars, and among them there is one so bright that it changed how humankind sees the universe. That star is named Isaac Newton. He was not only a scientist. Newton was a philosopher, a mathematician, an astronomer, the man who laid the foundation for the entire structure of human knowledge. Albert Einstein once said, "Newton was the greatest and most solitary intellect that the world has ever known." 3 centuries later, Neil deGrasse Tyson called him the most complete scientist in history. For with only a falling apple, he saw the rule that governs every object in the universe. With just a few strokes of his pen, he wrote the foundations of classical mechanics, building the first temple of modern physics. The story of Newton is not only the journey of a scientist, it is the story of a lonely and determined man who walked from the darkness of solitude to the summit of human intellect. The winter of 1642. England was drowned in the smoke and flames of civil war. In the remote countryside of Woolsthorpe, Lincolnshire, a premature child cried out on Christmas night. People said he was so small he could fit in the palm of a hand. No one believed he could live through the night. But he lived. And the fragile baby was given a name: Isaac Newton. A few months before he was born, his father, Isaac Newton Sr., had passed away, leaving behind a farm and a void that could never be filled. His mother, Hannah Iskar, later remarried a wealthy clergyman, leaving her young son in the care of his grandparents. And so, even before he knew the world, Newton had learned his first lesson about loneliness. In the grey stone house among the Lincolnshire meadows, the boy Isaac lived quietly, speaking little, always observing everything around him with thoughtful eyes. He did not enjoy the games of other children. Instead, he created his own: a water clock, a small windmill, a man-shaped kite flying across the fields. All were made by those small hands. Perhaps in those lonely hours, amid the sound of the wind brushing the thatched roof, the seed of a great mind began to grow. At the age of 12, Newton was sent to study at the village school in Grantham. At first, he was a poor student, mocked by his classmates. But one day, after being struck by another boy, Newton fought back. He swore he would never let anyone surpass him again. And from then on, he stood at the top of the class. His teacher, Henry Stokes, soon noticed something different in the boy's eyes. He loved to tinker, to ask why, and never accepted shallow answers. But when Newton turned 16, his mother called him home to manage the farm. Isaac, the boy who dreamed of stars, was forced to become a farmer. He hated the work, and his spirit withered among the quiet fields. Fortunately, Stokes and his uncle saw that genius could not be buried under soil and labor. They helped him return to school, and in 1661 he passed the entrance exams to the University of Cambridge. At Cambridge, Newton was a poor student who worked as a sub-sizer, cleaning rooms and serving meals for wealthy students in exchange for free tuition. But in the dim dormitory of Trinity College, the light of his candle never went out. He read Galileo, Descartes, Kepler, Hobbes, Boyle, poring over every line about physics, philosophy, and mathematics. While his classmates were absorbed in Aristotle, Newton chose a different path, the path of empirical science. There he learned how to doubt. He refused to accept any truth simply because others said so. He needed to see, to measure, to test, and to prove. and it was at Cambridge that the idea of a universe explainable through mathematics began to form in his mind. I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me. The 17th century, England was shrouded in fear. The Black Plague swept through London, claiming hundreds of thousands of lives. Cambridge shut down, lecture halls stood deserted, and every candlelight flickered out in the wind. Amid that despair, Isaac Newton, the young student from Trinity College, left the city and returned to his hometown of Woolsthorpe. There, only meadows, the sky, and silence remained. But it was in that silence that genius was awakened. The grey stone house of Woolsthorpe lay among fields of wheat. Every morning pale sunlight streamed through the window, falling across the wooden desk where Newton sat, surrounded by sheets of paper stained with ink and a few crude instruments. No one knew that the thin young man sitting there was rewriting the language of the universe. He recorded numbers, drew circles, then paused, gazing out the window. One afternoon, as the wind blew, an apple fell. In that instant, Newton lifted his head, his eyes following the glimmering arc of the falling fruit, as if the entire universe were whispering to him, and the world itself had fallen still. Newton watched the apple roll across the grass, and a simple yet immense question echoed in his mind. Why did it fall down? Why not sideways or upward? A childlike question, but the answer belonged to the cosmos. He realized there was an invisible force pulling the apple toward the earth. And if that force could pull the apple, then perhaps it could also hold the moon in orbit around the earth, and the earth around the sun. Everything was bound together by the same hand, gravity. That night, Newton did not sleep. He drew equations, tested calculations. Each number on the page seemed like a star shining in the night, and he was slowly uncovering the rhythm of the universe. To describe the orbits of planets and the motion of objects, Newton needed a tool that did not yet exist. So he created one himself, calculus, the mathematics that could measure motion and change, a new language to speak with nature. Differentiation let him understand the instantaneous speed of an object, like the breath of motion. Integration let him calculate distance, volume, and mass, gathering the essence of transformation itself. Through it, Newton could now draw the entire universe on paper, every planet, every falling stone, every flowing river. But the wonder did not lie in the formulas themselves. It lay in the way he could see order within chaos. In the wind that shook the leaves, he saw force. In the drop of water that fell, he saw trajectory. And in every movement, he saw a sacred harmony. From those notes, Newton formulated the 3 laws of motion. 1. The law of inertia. Every object continues in its state of rest or uniform motion unless acted upon by an external force. 2. The law of dynamics. The force acting on an object is equal to its mass multiplied by its acceleration, F ma. 3. The law of action and reaction. For every action, there is an equal and opposite reaction. These 3 laws became the 3 pillars supporting all of classical physics. From them, humankind would build mechanics, aviation, engineering, and cosmology. Even the spacecraft that would one day leave the Earth 3 centuries later. Newton foresaw a world ruled by reason, where every stone and every star obeyed the same laws. During those 2 years of isolation in Woolsthorpe, Newton accomplished what no one before him had done. He created a new branch of mathematics. He laid the foundation of classical mechanics. He discovered the law of universal gravitation. All of it within the silence of a small room. Later he wrote in his diary, "When the world outside was in chaos, my mind became the clearest." That is the paradox of genius. Sometimes loneliness is the most fertile soil for the mind. When the plague ended, Newton returned to Cambridge. The world outside had changed, but within him, the flame of knowledge still burned brightly. He began studying light. In his darkened room, he drilled a small hole in the shutter, letting a beam of sunlight pass through a glass prism. On the wall appeared a shimmering rainbow. People believed that white light was pure, but Newton discovered that white light was not a single color, it contained them all. Red, orange, yellow, green, blue, indigo, violet, each a wavelength, a frequency, a melody of the universe. When he turned the prism, the colors merged back into white light, proving that white light was a harmony of all colors. It was not just an experiment, it was the birth of modern optics. But Newton was not satisfied yet. He wanted to see farther. At the time, lenses distorted images because of chromatic aberration, colors separating, shapes blurring. He thought, what if we used mirrors instead of lenses? And so, in 1668, Newton built the first reflecting telescope. It was smaller, lighter, yet produced sharper images than any telescope before. Through that instrument, he saw the stars as no one had ever seen them, points of light that became worlds in motion. When Newton presented the telescope to the Royal Society, the scholars were silent. Not out of doubt, but out of awe. A young student with bare hands had changed how humanity looked at the heavens. 20 years later, in 1687, Newton published his masterpiece, Philosophiae Naturalis Principia Mathematica, the mathematical principles of natural philosophy. The book was thick, written in Latin, but every page was a diamond of knowledge. In it, he systematized the entire framework of the universe, the orbits of planets, the tides, the motion of falling bodies. He proved that both the heavens and the earth followed the same law. There was no longer a boundary between divine realms and human understanding, only reason and mathematics. When the astronomer Edmund Halley held Principia in his hands, he said, "We have seen the thoughts of God." 3 centuries later, Stephen Hawking called it the most important book in the history of science. From that moment, physics entered a new era. Centuries later, spaceships would still rely on Newton's equations to calculate their trajectories. The entire world became a vast laboratory for the human intellect. Before Newton, science merely described phenomena. After Newton, science explained their essence. He did not invent new laws out of nothing. He gathered the wisdom of those who came before him. Galileo, Kepler, Descartes, and built from them a complete, unified system. Newton once said, "If I have seen further, it is by standing on the shoulders of giants." That sentence became a timeless symbol of humility and gratitude toward knowledge. A person can be great, but only if he bows before the foundations on which he stands. When middle age came, Newton no longer confined himself to science alone. He stepped into another field, economics. In 1696, he was appointed Master of the Mint, the head of the Royal Mint of England. At that time, the country was in turmoil. Counterfeit money was rampant, markets collapsing, the people's trust vanishing. Newton, with his mathematical mind, began reforming the monetary system. He redesigned the process of minting coins, measured the weight of metals to the gram, and introduced machines to eliminate fraud. Within 2 years, he eradicated counterfeiting and restored stability to the British pound. It was not only a technical success, it was a victory of reason over chaos. Newton the scientist had saved the empire's economy. After his great scientific achievements, Newton devoted much of his time to theology and alchemy. He believed that matter and spirit were deeply connected. To him, discovering the natural world was also a journey toward understanding the will of the Creator. He wrote, "This universe could not have arisen by chance. It is the work of a being who is intelligent and loves his creation." In his laboratory, Newton was both a scientist and a pilgrim, seeking harmony between reason and faith. But even a genius bears the weight of solitude. Newton never married, never had close friends. He spent his entire life surrounded by books and a few servants. People said he loved a small cat dearly, and to make it easier for the animal to come and go, he had a craftsman cut a small hole in his door, the world's first cat door. Another time, while cooking, he accidentally placed his pocket watch into the pot instead of an egg, and smiled, realizing he had still timed the boiling perfectly. Such anecdotes made the cold, distant man seem unexpectedly warm. Yet Newton could also be extremely rigid and uncompromising. When Robert Hooke criticized his optical experiments, Newton swore he would publish nothing more until Hooke died, and he kept his word. Later, in his dispute with Leibniz over the invention of calculus, Newton used his authority within the Royal Society to defend his reputation. A battle that left both men's honor scarred. He was devoted to truth, yet sometimes consumed by it. Newton was knighted, becoming Sir Isaac Newton. He spent his later years in his house at Kensington with his beloved niece by his side. Wealthy, famous, revered as a symbol of science, and yet still alone. Each night the candle in his room burned late, its light reflecting on the old prism lying on his desk. People said he would sometimes sit silently for hours, watching the light shimmer without saying a word. Perhaps in that faint glow, he saw it all again: the apple, the meadow, the prism, and the universe spinning endlessly. March 1727. England awoke to a gloomy morning. A thick fog covered the sky of London like a thin veil. Inside a quiet house in Kensington, Sir Isaac Newton lay still in his bed. The last candle of his life still burned, its faint light flickering on his aged face, his eyes closed after a lifetime spent seeing through the depths of the universe. He passed away peacefully, without complaint, without anyone beside him except his caring niece. But outside, the whole world bowed its head. News spread across Europe. The man who illuminated the universe has died. Newton's body was carried to Westminster Abbey, the resting place of England's greatest figures. An endless line of people flowed through the ancient stone doors. When the coffin was lowered into the tomb, a beam of sunlight pierced through the dome, shining directly onto the marble slab engraved with Latin words, "Hic depositum est quod mortale fuit Isaace Newtoni." Here lies that which was mortal of Isaac Newton. Beneath it was the inscription left by those who came after. Let mortals rejoice that there has existed such and so great an ornament of the human race. That moment, a star was extinguished, yet its light would never fade. More than 3 centuries have passed since Newton's death. The world now has electricity, computers, the internet, artificial intelligence, but the equations he wrote still operate within every chip, every satellite, every piece of technology. When NASA calculates the trajectory of a spacecraft, it still relies on Newton's laws of motion. When students across the world study physics, they begin with F1 mer. When scientists measure the fall of light, they remember the man who first saw a rainbow in a prism. Newton laid the foundations of classical physics, upon which Einstein, Planck, and Hawking would later build, expanding toward relativity, quantum theory, and cosmology. Einstein once said a sentence that made humanity bow its head. Newton showed the world the path that I was only brave enough to follow. If human knowledge were a towering structure reaching toward the heavens, Newton would be its deepest foundation, solid, silent, and irreplaceable. But Newton did not only leave behind formulas, he left behind a way of seeing the world. Before him, people believed the universe moved according to the will of the gods. After him, humankind understood that everything could be explained by natural law. That idea opened the Age of Enlightenment in Europe, fueling science, philosophy, art, and faith in the power of human reason. He made humanity believe we do not need miracles to understand the world, only intellect and perseverance. Newton was the first to define science as a method: observation, hypothesis, experimentation, verification, and conclusion. That method became the standard, the foundation for every scientist after him. Thus, when we speak of modern scientific thinking, we are speaking of Newton's legacy. Yet greatness does not mean perfection. Newton was often lonely, proud, withdrawn for years because of disputes with colleagues. He was so absorbed in research that he forgot to eat, to sleep, even to be human. But perhaps that extremity was what made him a genius. Ordinary people seek happiness. Newton sought truth. And to him, truth was something worth sacrificing a lifetime for. Perhaps that is why he was always alone, not because he was unloved, but because he lived on a higher plane, a place inhabited only by light and numbers. People often remember Newton as a cold figure, white wig, dark cloak, proud eyes. But if one looks closer, one can see a simple man, a boy once abandoned, who grew up among meadows, enchanted by kites and gears. From a lonely child, he became the man who decoded the sky. From a boy mocked by others, he became the one before whom the world bowed. And from a small, quiet room, he taught humankind that the universe was no longer a mystery. It was something that could be understood. 300 years later, when humanity set foot on the moon, astronauts carried with them a small book, Principia Mathematica. They brought not just equations, but Newton's spirit, the spirit of a man who dared to look up at the heavens and ask, why? Newton proved that intellect can conquer destiny, solitude can create light, and the desire to understand is the most sacred drive within mankind. Though he has lain beneath the earth for more than 3 centuries, Newton's light still shines upon humanity. In every lens, every satellite, every computer, there is a part of him, the man who saw the truth hidden behind a falling apple. When we look up at the night sky, filled with billions of stars, let us remember that among them shines one called Newton, the star of reason, of passion, and of the eternal desire to conquer knowledge. If I have seen further, it is by standing on the shoulders of giants. And that was the full story. If you found this video helpful, don't forget to like, share, and subscribe to Stories and Documents, and turn on the notification bell so you won't miss any future episodes like this one. Thank you for watching, and goodbye for now.